welcome to the Chemistry Channel. So today we're going to be talking about ionic equations. And one of the most common reactions carried out in water is something called a precipitation reaction. So what is a precipitation reaction? A precipitation reaction is a reaction in which an insoluble product, and this insoluble product is called precipitate. So this insoluble product is called precipitate. So it is a reaction in which an insoluble product or precipitate is formed in a solution. So a precipitation reaction is a reaction in which an insoluble product is formed in solution. So a precipitation reaction is a type of metathesis reaction. Now, what is metathesis? Well, a metathesis reaction is also called a double displacement reaction. So it's also called a double displacement reaction. So let's draw out what a double displacement reaction or metathesis reaction is. So here I have a reactant with A and B connected together. And then we have another reactant of C, and then let's do orange, and D. So you're reacting these two different reactants together. So you have compound AB and compound CD. Now in a double displacement reaction, what happens is that D will switch places with B, and B will switch places with D. So in this case, you will form, so let's get our colors out. So we will form A, D, and then we have B, C, and then C was pink. So as you can see here, we basically have two different elements switching places. And that is sort of the key to understand metathesis reactions, is you just have two different elements, B and D, or A and C, switching places with each other. So that's why they call it a double displacement reaction. So how does precipitate form? So how does precipitate form? Well, precipitate, or insoluble product, forms when the force of attraction between two oppositely charged, so this means charged, ions is too strong for water to keep them apart. So you may remember from my previous video where I talked about the process of solvation. And remember that solvation is basically the process of water shielding the different ions and keeping the different ions from reconnecting to each other. However, when the two ions have extremely strong attractive forces that pull them together, this causes them to overcome this process of solvation and connect with each other, forming an insoluble product. So we can actually predict if a product will precipitate by using the solubility guidelines. So I'm sure you're all familiar with the solubility guidelines, and it's basically this table that tells you which combinations of cations and anions will produce soluble and insoluble products. So you can use this table in order to predict which products will be insoluble or soluble. Now, I'm not going to include this table in this lecture because it is found in every single general chemistry textbook. So you can basically just look up this table and use it to see which products are soluble and insoluble. But the general rule of this is that all group 1A, so this is the alkali metals, and NH4 plus cations in ionic compounds are soluble. And also, we know that all ionic compounds containing nitrate and acetate are soluble. So these are the two general rules that you should know about. So it's kind of upsetting, but the solubility guidelines were experimentally determined, and there really is no theoretical way in order to explain the behavior. It's just something that you have to have access to in order to determine whether something will be predicted to be soluble or not. So it's mostly experimentally determined. So it's experimentally determined. So it's experimentally determined. So we can use these solubility guidelines in order to write ionic equations. So now let's get into ionic equations. So ionic equations. Now, there are two types of ionic equations. Now, the first type that we're going to be talking about is something called the complete ionic equation. So this is the first thing that we're going to be talking about. So it is the complete ionic equation. And the complete ionic equation shows all strong electrolytes. And a strong electrolyte, remember, is an ionic compound that is soluble in water. So these are the ionic compounds that are soluble in water as ions. And those compounds that are insoluble or not soluble in water as the corresponding compound. So it basically shows all the strong electrolytes, and the strong electrolytes are the ionic compounds that are soluble in water as ions, and those compounds that are not soluble in water as their corresponding compound. So they basically will remain in the same form. So in order to show this, let's do one example. And we'll look into this reaction. So we have lead nitrate plus 2 sodium chloride compounds, which goes into 1 lead chloride and 2 sodium nitrates. Now, you'll notice here that I did not put any subscripts indicating the phases. So what I would like you to do is to look in your general chemistry textbook and use the solubility guidelines to determine which of these compounds will be soluble in water, and come back when you do so. So hopefully you did that, and let's write a little chart writing which compounds are soluble and which are not. So soluble and then insoluble. So the first soluble compound is lead nitrate. And that's because all ionic compounds containing the nitrate anion are soluble in water. The next one will be sodium chloride, and you should know this from experience. And so all group 1A metals are soluble. And then, of course, sodium nitrate is soluble as well. And the only insoluble compound is lead chloride. So lead chloride is insoluble. So now we can use this fact and use these predictions in order to indicate or write down the complete ionic equation. So these will all form ions, and this will remain as a solid. So now let's write the complete ionic equation. So in order to write the complete ionic equation, you write all soluble ionic compounds as their corresponding ions, and all insoluble ones you keep as their in their compound form. So let's write out the complete ionic equation for this chemical reaction. So you have 1 lead-2 ion, so this will be in the aqueous, and then 2 nitrates. So make sure you write your phases. So plus 2 chlorides. Now it's important to write your phases because it's telling you how the ions are interacting with the water. So lead chloride is insoluble, so it's a solid. And then 2 sodiums. And then 2 nitrates. So this is our complete ionic equation. So let's put a little bracket, and this is our complete ionic equation. So the complete ionic equation is very long, and we can simplify this. So we can simplify the complete ionic equation. So this just means the complete ionic equation. And we can simplify this by canceling out all common ions on the reactant side, so this means the reactant side, and the product side. So what do I mean by this? So let's go up here back to our complete ionic equation and cancel out all the common ions. So the first one that you'll notice is that we have a nitrate on the reactant side and the nitrates on the product side. So we can cancel this out. We also have 2 sodiums on the reactant side, 2 sodium ions on the reactant side, and 2 sodium ions on the product side. So we can cancel those out as well. So these 2 ions here are known as spectator ions. So these are spectator ions. So what is a spectator ion? A spectator ion is an ion that does not directly participate in the reaction. So it is an ion that does not directly participate in the reaction. And when we cancel out all spectator ions, we get the net ionic equation. So we get the net ionic equation. And the net ionic equation, so the net ionic equation shows all the ions directly involved in the chemical reaction. So it shows all the ions directly involved in the chemical reaction. So when we take out all of those common ions from the complete ionic equation, we get the net ionic equation. And when you do that, you will get the lead 2 ion plus the 2 chlorides going to lead chloride. And this is your net ionic equation. Now note that if the complete ionic equation contains all spectator ions, so if it, actually let's rephrase this. So if the complete ionic equation only contains spectator ions, no reaction takes place. And that's because you will cancel out all of the participating species, and therefore the net ionic equation will have 0 things within it. So that is it for the material for this video. And I thank you all for watching, and I hope I helped you understand the material a little bit better. And in the next video, we're going to be starting to talk about acids and bases and neutralization reactions. So I hope to see you all there, and I hope to see you all next time, and see you around, everyone.